Okay, next up we have Gyan from Starknet. Gyan will talk about the value of Starknet and the easy version of for those who are not really sure what Starknet is. So I have asked Gyan to especially have a time like this for people who are not senior developers yet or who are not really familiar with Starknet. So yeah, I hope you get a lot out from this.
Okay, awesome. So now that we have gotten through this small technical glitch, we are live. Hello everyone, my name is Gyan and I work as a DevRel at Starknet. I want to understand before I start this session as to how many of you know about Starknet? Like, have you heard of Starknet? Okay, I see one hand, two, three, four, okay. Any more hands? Okay, five. I've counted you by default, so that's good. Okay, so today in these set of slides, it's a bit more technical focus, but I'm trying to just talk about why Starknet, what is Starknet, and what was the problem statement that it is set to solve. So yeah, my name is Gyan. I'm based in Bangalore, India. I'm a Starknet developer advocate. And of course, two things that I love is helping more people learn about Starknet and helping onboard more women and non-binary folks into the Web3 space. So before we understand Starknet, let's understand the need for creating something like a provable program, right? Why do we need this? Why do we need to learn this programming language called Cairo? So imagine that you're a space scientist, right? And you have been given a project to send a missile to space, right? Now, in order to complete this project, you may have to think of different things, right? How do you save fuel? What should be the best launch window to launch your missile? And what should be the best trajectory that should be taken by your missile? And all of these are very critical components, right? This is a very critical mission. Maybe it could be associated with a nation. So all of these parameters that you need to calculate are very critical and could involve a lot of computation, right? What that means is trying to find answers for this particular questions by running things on computer, right? It involves a lot of mathematics. So you want to understand how to do this in the best way possible. So you will hire some bunch of engineers in your team and you will ask them to create some algorithms in Rust or any other programming language, right? So that they can run these programs on the computer and try to get the results for these parameters. So what happens? Your engineers will write some program, right? But now there is a problem. You have so much computation, you have so many parameters that you need to consider that you need a huge computer called as a supercomputer to run these calculations, right? And the other biggest problem is that only your rival country has a supercomputer. So you need to borrow this particular supercomputer in order to run these programs, right? And this is a very common thing. When particular nations have to do something for which they don't have the capacity, they will have to borrow that from either neighboring countries or other countries that have that capacity. So in this case, what you will do is your engineers will write the program. They will give this program to the supercomputer to execute that program. And the supercomputer will return a result, right? It will say that, okay, I will run all of these programs and here are your numbers. This is how you can save fuel. This should be the best trajectory, right? 18 degrees north or whatever. I don't know. I think it's completely wrong, whatever I'm saying. But yeah, it will give you all of these answers, right? After running this program. But if these answers are wrong, right? It can't be wrong because these answers are very critical for your mission, right? This is a missile. It can't just go on any other country and just explode, right? That will be a problem. So if these answers are wrong, right, how do you know if it is because this supercomputer malfunctioned that is something wrong happened with the supercomputer, or if this rival country tried to sabotage your algorithm, right? There is no way you can find out. And without knowing that, you can't blame the rival country that, hey, you know what, you gave me the wrong results and eventually my mission went to fail, right? So the problem here is, how do you trust that the supercomputer will execute honestly, right? You want to create a system so that anyone in the world can run things honestly without having to monitor them all the time, right? So right now, given this situation, you obviously can't trust them. So that's where this concept of zero knowledge proofs or ZK proofs that you have been hearing for quite a while, I'm sure, in the Web3 space, comes into picture. So if you write your program in this programming language called Cairo, right? This is a programming language that has been created to write programs which are provable programs. So what is the difference between the previous slide and this slide? It is that if you write a program in Cairo and you give it to this supercomputer to execute, it will not just give you a result, but it will also give you something called as a proof. What will this particular supercomputer prove? It will not prove that your algorithm is correct or not, because the supercomputer doesn't know about your algorithm. But your supercomputer can create a proof that it ran the exact algorithm that you gave the supercomputer, that nobody tried to tamper with that algorithm. So this supercomputer gives you a result of the algorithm that it ran given by you. And it also created a proof that I ran these exact steps that you gave me. So if the results are wrong, or if there is a malfunction, or if there is something wrong, if finally when the missile is deployed, it's on you, not on them. Why? Because you can easily verify the proof that is generated by the supercomputer. So if the execution of this program is intentionally or unintentionally modified, this proof cannot be verified, right? So this is the entire concept of how zero knowledge proofs work. And in Starknet, we use a particular proof type called Stark proof, which is a type of zero knowledge proof. And this computer, or any computer that runs the prover, can create a proof apart from the result. And you just need to verify if that proof is correct or not, right? To make sure that whatever computation this computer is doing is an honest computation. So the final conclusion is, a regular computer or any computer is able to keep a supercomputer honest without having to monitor it, right? A regular computer is able to keep a supercomputer honest. Now, why do we need to learn this programming language? Because in most programming language, when an algorithm is executed, you can only produce one thing, and that is the result. But if you want to also create a proof, then you have to write the program in a provable programming language. And that programming language is called Cairo. So right now, Cairo is being used in Starknet. But it is a general purpose provable programming language that can also be used in other contexts whenever required. So Cairo creates provable programs, and along with the result, you will also get a proof. Proof verification can detect cheating or malfunctioning without re-executing the entire computation all over again. And a regular computer is able to keep a supercomputer honest. So why Starknet? What was the problem that Starknet was set to solve? Before this, I want to ask, how many of you are familiar with the Ethereum ecosystem? Ethereum? Have you heard of Ethereum? Okay, 1, 2. You raise your hand, but you put it down. Yes or no? Okay, no. Yes? Yeah. Ethereum? Okay, I largely see like this. Okay. So Ethereum's, just like a couple of other popular blockchains, is a layer 1. What that means is it is an execution layer which uses certain different algorithms called consensus protocols to perform executions using, and it's a blockchain network, right? So these type of networks are called layer 1s, that are native execution layers. So the L1 or Ethereum has a problem, and Brian spoke about it as well earlier in his talk. So I'll just cover this very briefly. The problem is that whenever you're running something on Ethereum, you produce something called blocks, right? That's the idea of blockchain. You produce blocks. That means you say that, okay, I will execute this program, and the result of this program is 42. So now all of these validators that are part of the L1 ecosystem will validate that yes, indeed the result of this program is 42. So they will re-execute this program. They will rerun this entire thing, and they will be like, yes, you are right. I have validated that the result of this program is 42. And you can see that you can assume that this is the amount of time that it takes to run that re-execution, right? And with Starknet, what you can do is, after you create a result, as I showed you before, you can also generate a proof, right? That this particular program's result is 42. So you not just execute the program, you also create a proof. And now all of these validators, instead of re-executing the entire program, have to just verify this proof. They have to verify that this proof is correct. So the amount of time that it takes to verify the proof is much, much, much lesser than the amount of time that it takes to re-execute the entire computation again. And this is one of the biggest pain points in Ethereum. And Starknet is a layer 2 that uses the idea of validity proofs to make sure that Ethereum can be faster. It takes less time because the computation takes less time, and therefore you pay less gas fees and you can have more transactions. You can increase the TPS in Ethereum. So just to give you a simple comparison from a visual perspective, right? So this is the amount of time that it actually, so X is the amount of time that it takes for the transaction to compute. So the more the transaction increases, the amount of time that it takes to compute the transactions keeps increasing. However, the time taken to verify the transaction is just log of that. So you can see that after a point in time, the time taken to verify the computation is quite less. So the more number of transactions happen on Ethereum, the amount of time that it takes will keep increasing and the network keeps getting congested. However, if you use this layer 2, which uses the prover verification system, the amount of time that it's going to take for the transactions to go through, even if the network is heavily loaded, is going to be pretty neutral. So it's going to be pretty less. And like I said, Starknet uses the concept of validity proofs, right? You generate a result and you generate a proof, and Ethereum will verify that proof. So what are validity proofs? When you compress a file into a zip folder, right, so that you can send the file easily, it takes much lesser time and it is more efficient. Similarly, think of a validity proof or a roll-up as when you compress a big computation into a small file, right? So just like compressing a file into a zip file, you can compress all of these computations into a small validity proof. You can roll up all of the computations together. You can generate a validity proof for that, and you will just need to verify that on Ethereum. So validity proofs are an implementation of zero-knowledge proofs, and they use zero-knowledge proofs to ensure computational integrity. What that means is you can keep a supercomputer honest without having to actually monitor it. What that means is doing the right thing even when no one is looking, right? And where do we use Starknet? So this is the biggest question that I get. by almost everyone, right? What are some of the applications that we should build on Starknet? What can we do on Starknet? Basically, the answer is anything and everything. Because a lot of people get confused because Starknet is built, uses the concept of zero knowledge proofs, but it's not about privacy. Like I mentioned, the idea of Starknet is to help scale Ethereum. That pretty much means that you can build any type of project on Starknet. So anything that you think will eventually have a lot of users. And I would assume that all of you want to build products like that, right? So you can build anything and everything on Starknet. It's just like building something on Ethereum or any other chain for that matter. So that's why ZK rollups is a misnomer, and we always use the term validity rollups because Starknet is not for privacy, it's for scaling. You can build privacy-based apps on top of Starknet as L3 layer where you can facilitate your own privacy-based algorithms. And these algorithms could also be based on ZK Starks or Snarks. But Starknet itself is a decentralized L2, a roll-up solution which is built on validity proofs. And Starknet uses a unique algorithm called Starks. There is another popular ZK proof algorithm called Snarks. Starks is scalable, transparent argument of knowledge. And Snarks has also been there for a while. So this is succinct, non-interactive arguments of knowledge. So a quick comparison between the both. You can see that Starks are more powerful in the long term because they don't need a trusted setup. That means they don't need a third party to provide something for this algorithm to run. And they are also quantum secure. There are a lot of algorithms right now that are ready to break quantum algorithms that are ready to break the different encryption cycles used in cryptography, but they are not yet implemented because we are waiting for quantum computer hardwares to come into play. And the moment they come, there are a lot of different cryptography schemes that can be easily attacked. So Starks use a specific cryptography schemes that cannot be attacked by quantum computers. That's why they are more secure. So I'm going to skip this. And I'm just going to do this, which is why Starknet. I've spoken about all of these points. One point I want to highlight is that Starknet is very, very new, right? It's a very new layer 2 because this Stark technology or the Stark research has taken quite a while to come into production. And because Starknet is very new, you have the opportunity to get involved and make really good products, right? And the earlier you get involved in a particular blockchain ecosystem, the easier it is for you to reap the rewards later on. Like if you see people who have been involved in the Ethereum ecosystem, 10, 12 years ago, they are now considered one of the OGs. Like they get lot of opportunities, right? And not just from a product perspective, but about, from a financial perspective as well. It's a huge incentive to get involved in a protocol very early on, right? And so that's why I would say that why it is advantageous for people to get started with Starknet now is because right now, because Starknet is new, from us, we are willing to provide support to developers to build on top of Starknet. So if you are building a product, we are happy to support you in whatever way possible. And second is that Starknet is very robust, right? It is not kept in mind thinking that it's just like a small one-time project, right? This is a long-term project which uses very intense technology. So Starknet is here to stay. So even if you're thinking of building something which is 5-10 years down the line will become a unicorn, I would say it's worth starting out now and exploring. And third and the last thing is, right now the community is very small, so it is also very intimate. Anyone and everyone is ready to help you. If you have an idea, you can brainstorm with us. If you need developer support, we can help deploy developers with you. If you need builder grants, then we have those programs. If you want to contribute and build the ecosystem, we are happy to support you. So I would say not just for Starknet, but even otherwise, it is always beneficial to become an early mover in any blockchain ecosystem where you think the technology is very strong. So because Starknet is a very strong technology, this is the right time for you to get involved in it, learn more about it. And you have a lot of events and things that are going on, like Door Labs is doing a great job creating awareness. A lot of local communities as well that are trying to hold meetups. So I would highly suggest everyone to kind of, get into this ecosystem, explore. And if you need more help, then, we are always there to support you in whatever way possible. So yeah, that was pretty much my sales pitch to get started with Starknet. But yeah, I have all of these is just like architecture and all that. See, I have some resources. Yeah. So for those who want to know more about Starknet, we have a Starknet book. So this has like everything about Starknet, not just for developers, for everyone. So you can read the chapters that you are interested in. If you're specifically interested in learning Cairo, which is the programming language used to write smart contracts, then you can scan that QR code. And these two, I would say, are like one of the best resources to get started. All right, thank you everyone, and I will see you shortly.